Okay, so this question says graph the parabola from question 3. Find and label each of the following. So we got the zeros, the vertex, the y-intercept, and the axis of symmetry. All right, so let's go take a look at question 3 here. There's a whole bunch of stuff going on. We know the question is y equals x squared minus 6x plus 8. So this is the equation written in standard form, and I can find from standard form what happens when I plug in x equals 0. And that's what's known as the y-intercept. So when I plug in x equals 0, here's x equals 0 here. So somewhere along the x-axis, right? When I plug in x equals 0, I'm going to get 0 squared is 0, so that's going to cancel out, minus 6 times 0. So the y value when x equals 0 is 8. So I get to go plot that. So 0 and 8, which tells me from standard form I'm able to figure out what the y-intercept is going to be, right? So that takes care of the y-intercept, okay? Now, we answered something else in the other question. We factored this trinomial to produce something into factored form, which appeared right here, okay? So I'm just going to rewrite that. So when I factor that trinomial, I get left with x minus 2 times x minus 4, right? Because I needed two numbers to multiply to 8, but add to negative 6, right here, okay? So there are my two numbers, negative 2 and negative 4. Now to figure out, we're ultimately trying to figure out the zeros now, right? So where the graph is going to cross the y-axis, or the x-axis, sorry. And that occurs when when y equals 0. So anywhere along this axis, here, we'll do it in a different color. Anywhere along here, the y value, or the up and down value, is 0, right? So I know that if I set this thing equal to 0, so y equals 0, right? Then I'm going to be left with x minus 2 multiplied by x minus 4, okay? Now I can solve each of these individually, so I need to find out where this one equals 0 and where this piece here equals 0. So I can go x minus 2 equals 0 and x minus 4 equals 0, right? So that's going to result in x equals 2 and x equals 4. Okay, so those are my two zeros, right? So we'll do these. The zeros will be in red. The y-intercept will be in black. So here are your zeros. So at positive 2 and at positive 4. Okay, there's the zeros done. Now, here's the other piece. So I always found, okay, well, I need to find the axis of symmetry, right? We'll do this in blue. The axis of symmetry occurs in between the two x-intercepts, right? So if I find the middle of these two values, right, that's my axis of symmetry. So let's go find the middle of those two values. Well, I see I can go one this way and one that way. So there's my axis of symmetry right there at 3. Right? So this will be my axis of symmetry at x equals 3, right? That takes care of that. And the last thing is figuring out what the vertex is. Okay, and we'll do this in kind of a green, right? So much like what I did earlier when I found the y-intercept and I plugged in x equals 0, and I got a y value. It's like a machine, right? So this thing's like a machine. Right? We can figure out what happens. And so this is also just another version of this, right? So we can find out what happens when to y when I plug in any value of x anywhere, right? So I'm going to pick this one here because it looks a little bit easier, right? So I need to find out what happens when I plug in x equals 3 into this equation. I'm going to get a y value, right? But I'm going to plug it in. So it's 3 minus 2 multiplied by 3 minus 4, right? And that's going to be 1 multiplied by -1, which is -1. So that means that when I plug in the value of x minus 3, I know the vertex has to lie somewhere along this line. I don't know where, but that's the purpose of doing this, to tell me what y value it's going to be at, right? So in this case, I found out that it was going to be at -1. So I go find -1 and I plot it right there, right? And then my final step would be to connect all the dots to produce the parabola, right? But here's the catch. I see something interesting here, and I know that this here is my axis of symmetry. And you'll notice that this point here is an equal distance from that point, right? So that means that this point here must be an equal distance. There's only 3 units, 1, 2, 3, from the axis of symmetry, which means that there must be a point over on this side, 1, 2, 3, right here. So it's at this point now that I can graph my parabola and connect all the dots, right? And there's my parabola, right? And I suppose the final thing we could say here is to write, could write the vertex as being 3, -1. And that's